Hello students, welcome to the 34th lecture on linear algebra. In this video lecture, I will be discussing the proof of rank nullity theorem. Before discussing the proof, let us recall some facts which are required. So, null space is nothing but the collection of all x coming from Rn which satisfy this equation, that is Ax equals to 0, where A is any m cross n matrix. Fine. And the dimension of null space is also referred to as the nullity of A, and which is generally denoted as nullity of A. One more important fact, if the rank of A is R, then there are n minus R free variables corresponding to the system. Fine. And we might suspect that this n minus R is nothing but the nullity. And that is what we will be proving in this lecture, that whatever we have suspected was right. Fine. And let us try to understand what this point means, because this is one of the very important point. Fine. So what I have claimed in this, if A is any m cross n matrix, so I have chosen any m cross n matrix. Fine. And the rank of A is R. So if I say rank of A is R, it means once I convert this matrix into row reduced echelon form, you can check my previous video lectures to understand the concept of row reduced echelon form. Link is mentioned in the description box. Once we have converted this matrix into echelon form, and I am claiming that the rank of A is R. So it means after this R is the last pivot, fine, and all other entries, all other rows after this is 0. So we have basically n minus R columns which corresponds to the nullity. Now let us understand again this with a very easy example. So I have chosen any 4 cross 5 matrix, fine, and I have taken the rank of this matrix to be 2, fine. So if the rank of this matrix is 2, fine, so the value of R is 2, and you can see these are the two pivots, okay, right? So the value of n is 5 here. So what I need to claim is that n minus r, that is 5 minus 2, that is 3 columns. So what are those 3 columns? That is this. First is this row, first is this column, second is this column, and third is this column. So these columns corresponds to the free variable in the solution of the system Ax equals. What we suspect is that these are the n minus r which are contributing to the nullity. Now we can easily verify this thing also, because if we say that Ax equals to 0 is a system, and if I try to solve this system which I have already considered in the above example, so you can see that you get a system of equations. So these three are the free variables. So we can say that the nullity is 3. Now let us try to understand this full concept using the concept of a rank nullity theorem. So what is the statement of rank nullity theorem? The statement states that for any m cross n matrix, rank of A plus nullity of A is nothing but n. Okay? That is, what is n? The number of columns of A. Fine. So that is our statement. So the first thing is if the rank of A is n. Fine. If the rank comes out to be n, so n plus nullity is equals to n. So the nullity comes out to be 0. So if rank of A is n, then by the invertible matrix theorem. So we have invertible matrix theorem which states that a matrix A is invertible if and only if the following things hold. So both of these things are equivalent. That is, if A has n pivot positions, then the equation Ax equals to 0 has only trivial solution as x equals to 0. So this thing we will be using in the first case. So if the rank of A is n, so you can just easily verify the rank of A is n. So if rank is n, it means the equation has only trivial solution as x equals to 0. So that is what I have been so that is what I will be using here. So then by the invertible matrix theorem, the only solution to Ax equals to 0 is the trivial solution, that is x equals to 0. Fine. And if x equals to 0, it means the null space is only containing 0 element. So the nullity is 0 and hence the star. So I have marked this equation as star. So star holds trivially. So important is case second. So the case second states if the rank of A is R, which is certainly less than n. So then what I can say is in this case there are n minus R. So n minus R free variables in the solution to Ax equals to 0, as we have already seen in the above example also, and this thing is positive. Fine. And now let me call these free variables as t1, t2 and so on to tn minus 1. So these are any free variables, okay, chosen as those variables not attached to a leading one in any row reduced echelon form. Fine. So the next step is let x1, x2 and so on to xn minus r denote the solution obtained by sequentially setting each free variable as a 1. So what I will be doing is I will be sequentially setting each free variable equals to 1 and the remaining free variables equals to 0. And I will be saying that the solution corresponding to this will be x1, x2 and so on to xn minus r. Fine. And now what I will see that these x1 up to so on to xn minus r, they are linearly independent. Fine. So if they are linearly independent, now second thing which I will be proving is that they span full null space. And if these two things holds, then I will say that they form the basis and hence we can talk about the dimension. So that is the approach which I will be using in this theorem. So every solution to ax equals to 0 is a linear combination of x1, x2 so on to xn minus r because they are linearly independent. Fine. So I can write any x as a linear combination, that is t1 x1 plus t2 x2 and so on to tn minus r x n minus r. Fine. Which shows that x1, x2 and so on to xn minus r spans the null space A. Fine. Because x was any element, x was any arbitrary element. Fine. So thus they form a basis, and if they form a basis, so we can talk about the nullity. Why? Because they form the basis for the null space. So we can talk about the nullity now. So the nullity comes out to be n minus r, and if the nullity is n minus r, and that is the result which I want to prove. So and hence the result star holds. Now let us try to understand the proof with an example. So I have considered any A matrix, fine, with the following entries. So this is a basically 3 cross 4 matrix. Now you can convert this matrix into the row reduced echelon form and you will be getting this. So clearly the rank of this matrix is 2 because we have 2 pivots here. Fine. Now just try to solve this. So the equations corresponding to the first row will be x1 plus x2 plus 2x3 plus 3x4 equals to 0, and the second equation will be x2 minus 7x3 minus 7x4 equals to 0. So you can clearly see that there are two free variables. So there are two free variables, namely x3 and x4. So I'll be choosing, or I'll be letting these free variables as t1 and t2. So let x3 equals to t1 and x4 equals to t2. So you can calculate the value of x2 from here then. So x2 will be 7x3 plus 7x4, and what is the value of x3? That is t1, and x4 that is t2. So x2 comes out to be 7t1 plus 7t2. And what is your x1? Just substitute the value of x2, x3 and x4 in terms of t1 and t2 and just find out the value of x1. So the value of x1 comes out to be minus 9t1 minus 10t2. Fine. Now, what about the null space? So if I am talking about the null space, it means what is the value of x1? So the x1 was this. So I'll just substitute it here. What is x2? That is 71 plus 72. And x3 equals to t1 and x4 equals to t2. Now I can write this as t1 times minus 9 comma 7 comma 1 comma 0 plus t2 times minus 10 comma 7 comma 0 comma 1, where t1 and t2 are any reals. So what you can see is that is the null space is spanned by these two vectors. Fine. And clearly these two are linearly independent vectors. Since the two vectors in this spanning set are not proportional, so they are linearly independent, and a basis for the null space A, that is they form a basis. So the nullity comes out to be 2. Now we can verify. So we have A to be a 3 cross 4 matrix. So by the rank nullity theorem, so this was m cross n. So the n is 4 here. N was 4, and we have already seen that the rank of this A matrix was 2. So the value of rank is 2. So just apply the rank nullity theorem. So the rank plus nullity is equal to the number of columns. Fine. And the number of columns were 4. Fine. What was the rank? 2. And what was the nullity? We have already calculated, that is 2. So this comes out to be 4. Left hand side also 4, right hand side also 4. And hence we have verified the rank nullity theorem. So I hope you have understood this problem very clearly. So we have applied all the steps which I have used in the theorem in this question so as to make you people clear how this theorem is working. So I hope you have understood this video lecture very clearly, and in case if you are facing any problem, you can discuss or mention your problem in the chat box, or even you can email to me. Thank you very much for watching this video lecture. For more such video lectures, subscribe to my YouTube channel and do not forget to press the bell icon. Thank you.